Next example 15.1. Water is pumped at the rate of the 1,300 liters per minute, okay, through a centrifugal pump operate at the speed of the 1,750 rpm. The impeller has a uniform blade, height b 5 cm and R1 is 4 cm, R2 18 cm. The exit blade angle is beta 2 is 20. This one is the beta 2. The exit blade angle. Assume the ideal flow condition at the tangential velocity component v theta 1 of the water entering the blade is 0. So alpha 1 is 93 degree. Determine the tangent velocity component v theta 2 at the axis. B. The ideal head rise. C. The power build-up transfer to the fluid. Discuss the difference between ideal and actual head rise. Is the power ideal or actual? Okay, so this is the rest of the above data. We have Q angular velocity, width, the radius 1, radius 2, beta, and v theta 1 is 0. We want to find the v theta 2 hi and power of the water out of the pump. So next we just draw the velocity vector or triangle of velocity at the point 2. That is the point 2. This here, point 2 expand. Okay, so that is the velocity vector at the point 2. You see that the velocity v2 on this way, v2 is moving down because of angular velocity is clockwise. So okay, and we can write the equation that v2 is equal to u2 part u2 based on this equation, and we can write that cot beta 2 is equal to, this one is cot beta 2 okay, cot beta is equal to, so this length is br2 VR2, yes, okay. This length VR2 is mean the is equal to this length. So this is v theta 2 to this point. So for v2 we divide into VR2 and v theta 2. And the difference between on the top is the difference between u2 subtract v theta 2 divided by VR2. Okay, that is the cot beta. And we can find what is the u2 velocity of the blade at the point 2 is r2 omega. So just times the radius with the angular velocity. You convert to radian. So velocity of the u2 is 33 meter per second, and for q is equal to 2 pi r2 b2 and br2. Okay, so vr2 is equal to q divided by 2 pi r 2 b2. We substitute the q 5,300, convert to cubic meter and minute second. Okay, so we got the VR2 is 1.6 meter per second, and cot beta 2 from above equation V2 subtract V theta 2 so we can find V theta 2 is equal to U2 is U2. To 33 subtract the VR2 1.6 cot 23 degree. So at the point 2, tangential velocity is 29 meter per second. Okay, we move to part B. For it rise from U2 time theta 2 by G divided by G. So for the head rise is the ideal head rise 98 meter from equation 15. Another method. Is a long equation U2 square divided by G U2 VR2 cot beta 2 divided by G. Okay, so we substitute in. So we got the same head rise based on another equation. And part C, from equation 8, W sharp is equal to rho Q U2 V theta 2. Okay, we just substitute rho is 1000, Q is 5300, U2 33, and V theta 2 is about 84.5 kilowatt for the power. Okay, and we can find another method that V sharp rho GQ HI is about a little bit smaller, higher, 84.9 kilowatt hour. We can show that H actual is a little bit less than H rise because of the, but this one is the 89 is a bit is a greater than 84.5. Okay, so because H actual is less than H rise because of the energy loss.